Every autumn, a young robin does something that should be impossible. It has never made the trip before. No map, no bird to follow, and it flies mostly at night, alone. And somehow it goes the right way, for hundreds of miles, toward a place it has never seen. A bird that weighs less than a slice of bread knows which way is south. How? How does it know which way is south? For half a century, we have known part of the secret. Birds can sense the Earth's magnetic field. They carry a compass. What we could not explain was how. And the best answer we now have is stranger than anyone expected. The compass may not be a tiny magnet or a nerve. It may be a piece of quantum mechanics working inside the bird's eye. In our last episode, smell. A beautiful quantum idea mostly did not survive the evidence. This one is the opposite. This is where the strange explanation has largely held up. Start with why this was so hard. The Earth's magnetic field is real, but absurdly weak, about 100 times weaker than a fridge magnet. Far too faint to push molecules around inside a warm, jostling cell. By the ordinary accounting, the signal should be drowned out completely. And yet, the birds clearly do it, and their compass has one crucial quirk. It only works in light. Take away the light, and the bird loses its magnetic bearings. That pointed scientists away from any simple magnet and toward the eye. Here is the idea that now leads the field. When light hits a certain protein, it may knock a single electron across to a neighboring molecule. Now, two molecules each carry one lonely, unpaired electron. Chemists call that a radical pair. Now, the heart of it, in plain terms, each electron carries a property called spin. Picture a tiny spinning top inside each one. In our pair, there are two of these tops, and the only thing that matters is whether they spin in step or out of step with each other. In step, paired and balanced, physicists call a singlet. Out of step, parallel, they call a triplet. And here is the quantum part. The pair does not hold still. It wobbles back and forth between in step and out of step, over and over, very fast, like two dancers falling into rhythm and out of it again. Please keep in mind that this is an analogy to explain a concept that is more nuanced. That wobble is the whole trick, because the two arrangements have different chemical fates. So how much time the pair spends in step versus out of step decides what the cell ends up with. It is a molecular coin. And the Earth's field, far too weak to move anything, only has to nudge the rhythm of that coin, and the size of the nudge depends on which way the field points. Turn the bird's head, and you change the odds. The field is not pushing the bird. It is gently loading a quantum coin, and the cell counts how it lands. If that is right, the compass should live where the light-triggered chemistry happens, and the light requirement gives it away. The eye. The leading candidate is a protein called cryptochrome, variant 4, Cry4, sitting in the retina, the same tissue that turns light into sight. So the robin may not so much feel the magnetic field as see it. Scientists imagine that what a bird sees is a faint pattern of light and shadow laid over its ordinary vision, shifting as it turns its head. A moving stain on the sky that only the bird can read. For years, this was an elegant story in search of hard proof. Then, in 2021, a large team led by Henrik Moritzen and Peter Hoare did something decisive. They grew the Cry4 protein in bacteria cultures and tested it directly, and found its chemistry really is sensitive to magnetic fields. And more tellingly, the robin's version was more magnetically sensitive than the same protein from chickens and pigeons, birds that don't make long night migrations. The molecule that ought to be the sensor behaves, in a test tube, exactly like a sensor should. Now, I have to keep the promise this series makes, and tell you where the edge really is. Showing a protein is magnetically sensitive in a test tube is not the same as showing a living bird uses it that way to steer. That full chain, from chemistry in the eye to a signal the brain reads as direction, is not yet nailed down. It is the leading hypothesis, strongly supported and still open. And it is tightening in real time. Just last year, some of the same researchers looked at a close variant, Cry4b, that had been floated as a sensor and largely ruled it out. That is not the theory failing. That is science narrowing its own claim, one careful subtraction at a time, focusing the search back where it belongs. Here is what I most want you to take with you. No single field could have caught this. Ornithologists asked the question. Behavioral ecologists found the strange rules of the compass. Quantum chemists proposed the mechanism. Molecular biologists found the protein. Physicists simulated the wobble no one can yet watch in a living cell. The answer sits in the seam between all of them and belongs to none of them alone. The flagship review even says so out loud. To make progress, someone had to explain the chemistry to the biologists and the biology to the physicists. And underneath it all is the wonder. This is real. Evolution built a working quantum instrument and wired it into an animal's eyes millions of years before we had the math to describe it. A small brown bird has been running a quantum physics experiment every autumn night, and we are only now catching up enough to notice. So I want to hear from you. What is something in the natural world that stops you in your tracks that you suspect no single subject could fully explain? Tell me in the comments. Those are exactly the questions this series is for. One more thing before we close. If chasing a question across more than one field is something you would like to build in yourself, our free idea ranker is a small tool for finding where your scattered interests actually connect. The link is in the description. A small bird over a dark field is, at the same time, a problem in biology, in chemistry, in physics, and in wonder. You do not have to choose which one to be curious about. You are allowed to be curious about all of them at once. Remember to be curious as children and stay Renaissance. Let nature surprise you.